Another horizontal circle, and again, another car driving around a roundabout. We will get to when it's not a level roundabout, but for now, level roundabout means the normal is straight up. Gravity is always straight down. I'm picturing it turning to the right, and I'm going to call this F to turn the car. For every circle, it sets up as an F net equals ma because it's accelerating. Because it's going in a circle, it's accelerating with the rate of v squared over r. In this particular case, there's only one force making it to turn, causing it to turn, and that's the F turning force. The logic step is at the maximum acceleration, the turning force is equal to friction. You can't accelerate anymore. Friction is what determines how quickly a car can accelerate. So we can replace F turn with the force of friction. Force of friction is mu times Fn. I forgot to do the vertical component. The way this one's worded, oopsie daisy. It doesn't say anything happening vertically. It's not a banked curve. It's not flying up or down. So the normal is equal to gravity, which is mg. So we get mu mg equals mv squared over r. The m's are going to cancel out. If we rearranged for v, we get that v squared equals r mu g equation. We saw that in the last question. This particular one, the way I've worded it, we're looking for the mu. Mu all by itself is v squared over rg. For the numbers in this one, the car is going 54 kilometers per hour. The radius is 25, and we're looking for the coefficient of friction. I gave you the mass of the car, but it ends up the mass of the car doesn't matter. One little thing, 54 kilometers per hour, we need to deal with that. The conversion factor is 3.6. It works out cleanly to be 15 meters per second. So plugging that into our mu, it's 15 squared over, oops, what was your 25. 15 squared over 25 times 9.8. Doing the math on that, I'm getting a mu of 0.9. That's the minimum coefficient of friction. If the coefficient of friction was larger than 0.9, that'd mean there's more than enough friction for the car to make the turn. But if there's any less, then there's not enough friction. The car would have to slow down or it would slide